Welcome back. So the last video we did is we covered question marks and what they do in C#. And this time what we're going to do is we're going to cover some more basics around properties and fields. So why I wanted to do that here is because in the second programming assignment, there's a requirement that you have the weight of an assignment at what I refer to as the type level. So what I'm saying there is there are really two design methodologies that you could use to implement that feature. Either you could store the same weight duplicatively over every object of that type that you're going to create. So if you create 80 homeworks, all 80 of those homeworks would store the same weight 80 times, which doesn't make a whole lot of sense. The alternative is to have effectively a static member on the homework or the quiz or the whatever type that allows you to store the value only once, and then that would be referenced by every object of that type. There's a little bit of nuance there. So one of the ways that you would be able to do that in something like C++ is you would try to expose that as a read-only or a constant field, so that people don't modify that weight after the fact, and it would basically just be a static at the parent level that would then be inherited by the child, or it could be a separate child static member for every type. In C#, in order to kind of check both of those boxes off, there are many different ways you could do it. One of the most powerful or the kind of easiest ways to do it is to use properties rather than fields, and the reason is that properties have business logic that can be overridden as part of object orientation's sort of inheritance feature, while fields do not necessarily support virtualization. They don't have business logic that can be overridden by a derived class. So the field is basically what you see is what you get. It's basically just a data member. It's somewhere to put data, and that's it. So what we're going to do is we're going to go through this sample code that I have, where I have outlined some of the most common patterns for expressing properties and their relationship to a backing field. So I'm going to explain what the heck a backing field is, and then I'm going to explain what a property is and how you can use all the various different method modifiers to make your getters and your setters do interesting things, which is not a thing that we've actually covered in the class. We've sort of theoretically talked about the difference between a field and a property, but now I want to make that much more concrete for you to hopefully use in the second programming assignment. So without further ado, what we have previously talked about is properties versus fields, as fields are basically just data. Properties are data with additional business logic that allows you to scrub data. So you can make sure that proper names or proper nouns are capitalized when you set the value and when you retrieve the value. And it's nice for CRUD applications because you know that the data is being cleaned automatically on an ad hoc basis whenever it's being accessed in the class layer. Alternatively, you can actually use whatever business logic you want. You don't necessarily have to use data validation or anything like that. You could run anything. It's sort of arbitrary code point. So we're going to start with the very basic property, and that very basic property is something that looks like this. So what this is again syntactical sugar. This basically is just saying that I have a default getter and a setter, and so this thing is going to act exactly like a public field. This thing is not running any sort of business logic, and the reason is because we have specified a default get and a default set. And so remember that this is basically just shorthand for if I have a private string property, and then I have a public string property, and all it's doing is doing a get which is return the backing field, and a set that is setting the backing field. And we're done. So you can see that this thing is now grayed out, and what it's saying is that I can use the auto property, and if I use auto property, then magically I get back to exactly what it was. So if I control Z that, this whole kind of just long-winded thing ultimately rolls up into this. So one of the things we talked about last time is there are optimizations that you can do, and I'm going to talk about micro optimizations in a fair amount of detail with some anecdotes in the architecture discussion. But one of the very common kind of micro optimizations that you can do is something like this. If the property is not equal to the value, then set the property equal to the value. Excellent. So what's happening here is we are saving one assignment statement. So effectively one, we hope one bit of intermediate language, one line of intermediate language, in the case that the property is being reset constantly to the same value. You see this stuff happen all over the place in UI. So if you're coding using events, and those events are constantly firing, those events will come through here and potentially nothing has happened to a field that is bound to a text box. And so the value that's bound to the text box will constantly be setting the property, and you will constantly be hitting this line of code. If you have this conditional statement, what you're effectively doing is short-circuiting that. You're saying only hit this line of code if you're going to do this, if you have this difference, if there's actually an update. And so what can happen is this is a micro-optimization because ultimately you will eventually get into a situation where branch prediction will help you. It will say this thing has been updated 1,000,000 times and only once has it actually ever resulted in a set. And in that scenario, you do gain something. It's not a lot, but it's something. I think for most applications in the class that this is entirely fine. So this thing provides no additional benefit for being a property versus a field. It's just a default property and everything's kind of cool. So I can access this by doing something like example dot, well, if I could type example dot property equals my property. And so if I did something like console dot write line and did example dot property, then I can expect to see my property written out to the screen. And so if I look over here, that's exactly what I get, my property. Everything is cool. So what you have in the second programming assignment is you have a situation where you want to be able to access a value, but you don't want anybody to ever be able to modify it. And so basically what you have is you have the need for a constant value. You can implement a constant with a property that has no setter. And so here we have property no set. And if I go into example property, and so I can go example dot property, property no set my property, and what will happen is I will get a syntax error that says, hey, this thing can't be assigned to, it is read-only. The reason it's read-only is because I don't have a setter. I only have a getter. And in this getter, I am returning just a string literal. So the only thing the property no set will ever return is the literal string no setter. So if I go in here and do console console dot write line example dot property no set. Nope. Save that and run it. What I'll get is no setter, which is exactly what I would expect. And so this fulfills the role of having a read-only property, but it has the added benefit of being able to be virtualized. So this is dumb business logic. Doesn't actually make a whole lot of sense, but I could also have a public virtual version of this. So if I have a derived example class, I could have an override here that returns a value that is different from no setter. So you can see how this might be useful for something like your programming assignment 2, where you could override this virtualized property with the actual weight of each different type of assignment. So a homework, a quiz, or an exam. So that this is explicitly why this conversation kind of exists from a practical perspective, but it's also a thing that you'll see over and over and over again as you code more complicated stuff. So this is a situation where you don't want a setter at all. There's also a situation where you want maybe only the class itself to be able to set the value. And so this is a private set. So in here, if I try to do something like example dot private set equals private, again, I get a syntax error. And the reason is because it can't be used because the accessor is inaccessible, which means I am in a different class. I'm outside of the scope. I can only actually set this property with a method inside of the class. And so if I wanted to actually set this value, what I could do is I could say example.set property private set, and then pass that value in. And this is an alternative to a setter that could have even additional business logic or 95 overrides or whatever you want to do. Effectively what you've done is you've taken your set value and you've abstracted its business logic way out here where I have to actually access this setter from within the class, either on a constructor or on an externally available method. So you can also see kind of the validity here. You can also see that IntelliSense is not always correct here. So right now it's saying that I could use an auto property, but in this case, an auto property would actually give me, oh, actually this is new. So you can do auto property here, and it's going to give you private. So here the auto property is just giving me this extra modifier, and what that's doing is it's saying that I still can't access from out here. I have to access from within, and so this is just again shorthand, exactly like the shorthand we had up here. So in this case, IntelliSense is fine. It's down here that it's kind of weird. So this is the follow-up. It is less restrictive than a no set. So this has got to return a literal or something, or some literal that's constructed from variables inside of the class. This can expose the set logic through a different method. And so we're going to see tons and tons and tons of examples of when this might be helpful. And we're also going to see in the design patterns lecture how we can use kind of these same ideas to implement a singleton in a kind of reasonable way without a whole bunch of hacks. So that's kind of nice. One final thing I want to touch on are called expression-bodied members. So this is a fairly new thing in C# 7. So I included a link in the code here if you want to go read about it. You can go out here. There's a whole bunch of information about exactly what it is and how to make properties read-only and whatever. But the idea is that instead of this fairly verbose syntax here where you're effectively providing method blocks, what you can also do is expose an expression. So this is expression syntax, which we're going to see a lot of in terms of lambda expressions inside of link queries and all sorts of stuff like that. It also turns out that you can use this exact same syntax to build methods. So if you wanted a public void method that just set the value, you could do this exact same syntax, except instead of a setter, you would be doing an actual method. And so it turns out that there is there's a non-trivial amount of research that exists in the software engineering research field that says that this syntax is way easier for people to comprehend than all of these squiggly braces. And the reason is because this usually indicates to the person that it's a fairly simple kind of thing. And you don't necessarily have to think about scope because the scope is on a single line. If you combine this with the kind of stuff that we talked about in the previous video where you have ternary operators and all that kind of stuff, you can easily see how you would get fairly verbose business logic, or very complex business logic, compressed down into a single line of code that you could then expose as an expression. And so these getters and setters work exactly the same way as a getter and setter that's inside of curly braces, except they're just in expressions instead of method bodies. And so we're also going to see this kind of stuff fairly commonly inside of multi-threaded programming. We talked about async and await. So this is just a good thing to know that this syntax can be used all over the place for properties as well as for method bodies, and it's something to kind of look out for as we go through the class. So if you don't understand or remember something from the lecture, this would be the thing. This is additional kind of accoutrement to the end. This stuff is more necessary for understanding what you're doing, and this stuff in particular will be helpful for you doing programming assignment number 2, because again, properties have business logic, which means they can be virtualized, which means that you can have derived classes provide overrides to these properties. So I hope that this is helpful, and if you have any questions, comments, concerns, please let me know, and I'm happy to sort of provide more context. Thanks for tuning in, and I will see you in the next video.